Hi everybody, and welcome to week 2 of an interactive advanced presentation. Today we are kind of going to be traveling back in time a little bit, and we are going to create lava lamps. These were extremely popular in the late 60s, and were seen practically everywhere in households back in that day. So it is going to be a chemical reaction, so we're actually going to be able to see it occur in front of us. So, things that we are going to be needing. You're going to be needing a clear jar. Be sure that it is clear just so that you can see the chemical reaction occur and of course see the actual lava lamp happening. You're going to be needing some water. You're going to be needing some vegetable oil. You can use any types of oil, but just be sure that they do have differences in density depending on the make that you use. You're going to be needing some food coloring. Right here am going to be using 2 types. And then, of course, you're going to be needing an Alka-Seltzer packet. This is what's going to cause the chemical reaction. However, if you do not have Alka-Seltzer packets, you can actually use salt, but the chemical reaction is not going to be as effective as an actual Alka-Seltzer packet. So let's go ahead and get started. So, your first step is you want to, for me, I'm going to open up my water, open up my jar, and you're going to be filling your jar about 1/4 of the way up. So it would be about right there. Okay, the next step is you want to be adding your vegetable oil. So this is where it gets interesting. When you add vegetable oil to water, you will notice that they actually do not mix well together. This is seen if you've ever made pasta before. It's where the bubbles kind of float on top of the water. This is because of the differences in density and the differences in the molecular makeup of the 2 molecules. Water is considered a polar molecule, meaning that the distribution of electrons and protons are unequal. That means it actually has 2 polarities on both a positive and a negative charge. The density of water is about 1 gram per milliliter or 1 gram per centimeter cubed. Vegetable oil, on the other hand, is a hydrophobic molecule, meaning that it does not actually mix with water. It is actually a water repelling or fearing substance. It is mainly created from hydrocarbons and has about the density of 0.91 to 0.93 grams per centimeter cube. Unlike the water molecule, vegetable oil actually is a non-polar molecule, meaning that there is no positive or negative pole, and that it is the electrical charge is evenly distributed amongst the molecule. And so because of the differences in that, you will observe the vegetable oil actually not attracting because of the polarity. So let's go ahead and look at that real quick. When you do this step, you kind of want it to be about 3/4 of the way filled, but just be sure you leave a little bit at the top. So let's go ahead and do that. Fill right about there. All right. So as you can see, there is a huge separation between my oil and my water, and the reason is like the polarity that we just talked about. So the next step that you're going to want to do is you're going to want to add your food coloring. Food coloring actually is a polar molecule, just like water, which means you should see the droplets pass the vegetable oil without mixing with it, and then the moment it reaches the water, you will see it mix. It is a hydrophilic component, meaning that it is a water-attracting molecule that it will mix with water. So for mine, I am going to be, you normally should add about 8 to 10, so I'm going to be adding 5 of red. 1, 2, 3, 4. That might be a little bit more than I originally wanted, but it'll be all right. 1, 2. add another drop there for good luck. All right. So if your food coloring isn't mixing just at the moment, you can gently shake your jar, as you can see, so it mixes all the way to the bottom. Currently, right now, I'm having droplets just kind of chill in between the water and the vegetable oil. Let me add a teeny bit more red. Come on now. There it goes. Looks like my orange isn't. Oh, there it is. All right. Make sure when you're doing this step that you do not spill your oil, because I almost just did. All right, there we go. So as you can see, we have our distribution. All right, so the fourth step, this is going to be the fun part. You are going to be taking your Alka-Seltzer packet. So Alka-Seltzer is basically let's see if I can open it. So Alka-Seltzer is made up of, essentially it is just citric acid, and sodium bicarbonate. So the chemical reaction that we actually will be seeing is citric acid plus sodium bicarbonate reacting with the water, the trisodium citrate, and carbon dioxide. So that is what we're going to be noticing. So you kind of want to break your Alka-Seltzer tablets up. I am going to be using 2. As the tablets travel through the vegetable oil, you should see no chemical reaction occurring. But the moment that it touches the water, you will start to see the chemical reaction, and it will create carbon dioxide gases or gas bubbles that will travel all the way through the vegetable oils in an upward direction to the top of the bottle. So let's go ahead and observe that. All right, and there it is. As we can see that it is working right there. And that is our lava lamp. So I'm going to be using another packet just because, or maybe not. It looks like it's doing a great job actually. Yeah, you can even see it bubbling. All right, so normally the limiting reactant in this experiment is the Alka-Seltzer packet, or the citric acid and sodium bicarbonate. The reason for that is the moment that the tablet is fully absorbed, as you can see, it has already absorbed a little bit. Looks like it actually floated to the top a little bit right here. But as you can see it be fully absorbed, the chemical reaction will actually stop, meaning that unfortunately your lava lamp has died. So let me add one more and see. And there you have it. It is going to be starting back up again. All right, so in this experiment, we used, like I said, the limiting reaction of an Alka-Seltzer packet. So what is a limiting reactant? That basically is a product that once it is completely consumed by the reaction, it will actually often determine the amount of product that is formed. And in this case, it will be the bubbles. I'll turn it around for you guys so you guys can see it a little better. One thing that some errors I am noticing is that my Alka-Seltzer tablets are actually floating up to the top. So that is definitely something we can be looking out for. Other than that, I hope you guys enjoyed it, and I hope you have a blessed day. Bye-bye.